Thanks. And the first step in the process is that your little molecule here, this helicase comes through and it unzips your molecule. So these are little SSB. These are single strand binding proteins. These come in and keep the strands of the helix separated from one another so they don't allele together as the helicase travels up and splits the molecule into two strands. This square represents RNA primase, DNA primase, I should say. It comes into these strands which have been separated by a helicase, and the triangles represent single strand binding proteins which separate the strands. It comes in and it puts a little primer on here, and that is where the RNA polymerase will then come and bind to and begin to transcribe this way. This strand here is known as the lagging strand, and it's called this because although this polymerase can travel straight from 5' to 3' without interruption, as the helicase splits, this strand has to take several steps to use primase to create an RNA primer, and then the polymerase travels up, and once it hits this spot, it has to stop, wait for the helicase to travel further up the strand, and then it'll put another primer on, then it travels up, and it's a slower process than the leading strand, which can go straight without interruption. After the mRNA, which was created in the previous transcription phase, is exited the nucleus and enters the rough endoplasmic reticulum, the two ribosomal subunits assemble around said mRNA with tRNA molecule right here already in place, ready to bind to the three-letter codons underneath, which correspond to a protein which is being carried, or an amino acid I should say, which is being carried by that tRNA. After the first initial binding, then this starts off in the P site, it then transfers over to the E site and is ejected out of the cell, out of the ribosome, and the tRNA, which was in the A site, transfers over to the P site, and the amino acids are polypeptide bonded together and transferred over, creating a long chain, and the process continues over and over until you have a long protein strand, which then enters a chaperonin and is folded to proper specifications.